So let's take another example. In this case, Proloquo2go. I think it's interesting because it is a little misleading in its layout, and that may be useful. So this particular screenshot was taken, I believe, on an iPad Mini 2, and certainly that's its target tablet. The screenshot is 2048 by 1536. The iPad Mini 2 has a screen size of 161.2 millimeters wide by 121.3 millimeters high. And so if you simply divide 2048 into 161.2, or the other one, 1536 into 121.3, those two ratios turn out to be approximately 0.079 millimeters per pixel. So you would still use the same techniques that we used in the previous video of going to Microsoft Paint or some other graphic program that you can use to take pixel level measurements of a screenshot. And when I did that, we'll start with just the outer parts of the app. This upper message bar was 20.145 millimeters after conversion from pixels. The upper command bar is 7.031 millimeters, and this lower command bar is 6.95 millimeters. One thing to keep in mind is that keyguard.scad, its input parameters only allow specification to a whole millimeter. So I put this information here, but that level of precision can't be entered into the program. So we'll just be dealing with 20 millimeters, 7 millimeters, and 7 millimeters when we actually put this data in. But what's going to be interesting here is actually the button region, because the buttons have different shapes, and those shapes make gaps a little confusing. For example, in some cases it looks like there's a big gap between buttons, and in other cases it looks like there's a little gap between the tab on this button and the button above, or a little gap between buttons horizontally. Well, we'll take a close-up here, I believe, on the next slide. But if you look closely, you see that this gap here matches the vertical gaps. So when you look at the tab on the button, the top of the tab vertically matches the gaps horizontally, which really means that a tabbed button is sort of the default button, and these things without tabs are just special cases where they've removed a tab. The grid is laid out by the Proloquo2go program as if it has to make room for tabs if you decide you're going to put a button with a tab in there. So what's interesting is the tab is the basic shape, and the distance between buttons is really consistently the same small amount. And we'll look in the subsequent slides, we'll also look at the distance between the array of buttons and the edges of the grid, specifically to see whether there's a relationship between this gap, which equals this gap, and the outer gaps. Will they be 1/2 of this distance? Because that's always the key measurement to determine whether or not a grid layout is balanced in some way. These distances are the same, and the outer distances, top, bottom, left, right, are 1/2 of this distance. So let's take a look. First of all, This is the distance up here again between the top of the tab and the button above, and it is, for all intents and purposes, twice this distance is twice this distance. And even though the space at the top looks larger than the space at the bottom, if you were to put a tab on these buttons up here, and I assume that you could put, these are group buttons, I assume they connect to other pages with examples of actions or descriptions where this is a single word choice. So you could put these group buttons up on the top row, I assume, and therefore there would be a tab up here, and then the distance between the top of that tab and the bottom of this command bar above is the same as this distance, and both of them are 1/2 of the standard inter-button distance. So that means, when I say here, so the layout is balanced from top to bottom. It may not look like it, but again, because you're not seeing the tabs here, but it is balanced in this direction. And when something is balanced, you don't need padding. So there's no need for padding on the bottom or the top. The layout will just work out properly. Now let's take a look left to right. Well, this is the right side, and it's a mirror image of what you'd see on the left. But notice that this distance here is not the same. Now, it's not twice this distance. In fact, this distance is much larger than simply 1/2 of that distance. So what do you do with this space here? We take this distance here and subtract 1/2 of this distance, and we'll be working with pixels initially, and see how much is left over. So this, it turns out, is 20 pixels wide. You take 1/2, well, this guy is 9 pixels, or 9 or 8, somewhere in that range. Take half of that, 4 pixels. So 20 pixels minus 4 pixels, and you get 16 pixels worth of extra. We would have loved to have this be just 4 pixels here, then it would have meant it was balanced from left to right as well. But there's 16 extra pixels. So figure out how much that is in millimeters. Well, do the conversion. 16 pixels times 0.079 millimeters per pixel equals 1.26 millimeters. We're going to round that down. And this is where we're going to add some padding. And it's only a millimeter of padding we're going to add on the left and the right. All right, so with that in mind, let's go and create the key guard. So our tablet is an iPad Mini 2. We're going to display the camera and home button. In fact, we're not going to even mess with a case in this example. The case just chops off borders as necessary. But we're not going to confuse this by talking about the case at this point. So that's really all I need when describing the tablet. We're going to skip the tablet case, as I said. So we'll say it has no tablet case. Our upper message bar height, if we look back at the PowerPoint slides, that was 20 millimeters high. Remember, we have to keep it at even millimeters. And we are going to display that. Then we have a upper command bar that is 7 millimeters high. And we're going to display that as well. And anytime you display both a message bar and a command bar right next to each other, there is no divider in between. And it has a lower command bar that is 7 millimeters high, but we're not going to display that. And last, we're going to do the grid. This Proloquo2go layout had 8 columns and 4 rows. The buttons are pretty close together, so we can go smaller than 5 millimeters rail width. If I take it down to 4 millimeters, I've got a rail height or key guard height of over 3 millimeters. I could take it smaller. Let me just experiment here. Let me take it even smaller down to, well, not that one. That doesn't have any effect in this case. Take it down to 3, but let's take the slope up to 80 and see what that gives us. So that gives us a 5 millimeter height. And again, we may experiment with this, or you could experiment with this to see if that's really what you want. And then we said we didn't need any padding on the top or the bottom because it's balanced top to bottom. But we were going to add 1 millimeter of padding on the left and the right. So let's look at what this is. That's really all we were going to do because we don't have a case, and we're just going to leave it as a no mount mounting method. So here's our key guard for that app. And I guess one thing to point out here is, again, because we have the grid starting directly next to something that we are exposing, which was that upper command bar, it's a relatively thin piece of plastic through here. I mean, that's not terrible. We can that's still very strong, especially since every few centimeters it's supported by one of these vertical rails as well. This might be just fine. You know, you could say, well, what would this look like if I took it to a 60-degree slope instead of an 80-degree slope? Could I make everything thicker if I made them 90 degrees? Yes, you would. You'd make them a full 3 millimeters wide at the top, not just at the bottom. But this should fit that app very well. And if we put it in a case, it would just trim off some of these outer edges, and we'd add some sort of mounting method for that particular case configuration.